All right, guys, we're going to go ahead and get started here on 4-5. First thing up is the warm-ups. Go ahead and pause the video, work through 1 through 3, and then play it back. All right, so here we go. Number 1, name the angle formed by ray AB and ray AC. So if you don't see this answer, what you're going to need to do is draw it. So we have the common endpoint here, A, for both rays. So you start with A. And we're going to draw AB. We don't know where the angle is, but it's a ray. But I can make the angle any size you want. And we have AB and then AC. So the angle formed is going to be angle BAC. This concept will be used as we go through our lesson dealing with included angles. Okay. Next up, number 2, name the 3 sides of triangle ABC. Again, all you're doing is, you draw a triangle. Triangle A, B, C. So you got, AB. It's a side. You have BC, and you have AC. Let's make sure you include all the sides. Okay. Number 3, and that's all you have here. Number 3, we have 2 congruent triangles, so we name all pairs of congruent and congruent corresponding parts. This is a review from the last lesson. So if I list my sides, I'll do that first. So my sides, we have QR and LM, the first 2 points in each. So if QR, that's congruent to LM. You don't have to say congruent, you can just say QR and LM because they're saying name all pairs of congruent corresponding parts. So just by listing them, you're saying they're congruent. But I'm going to write the statement out. So I have QR, and then I'll do RS. So segment RS is going to be congruent to segment MN, second and third points from each one. And then we'll do QS. So QS, not QR. QS is congruent to, again, first and third. First and third is LN. So those are your sides, and then your angles go pretty quick. Your angles are, again, just angle Q, which is congruent to angle L, angle R, which is congruent to angle M, and angle S, which is congruent to angle N. So those are your congruent sides, your congruent angles, those are your congruent parts. Okay, so there's your warm-up. So let's kind of talk about how we're going to use all this information in 4.5. So today we're going to be learning about 2 congruence theorems. Again, 4.5 and 4.6 kind of go together. You'll see that as we go through each lesson. For 4.5, we're going to learn about side, 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 and side, angle, side. And in 4.6, we'll learn about angle, side, angle, and angle, angle, side. Again, the concepts are going to be very similar, but in the previous lesson, we learned how to prove triangles congruent. And we learned it by showing all corresponding parts were congruent. Well, with these theorems, we don't have to show that everything is congruent. We just need to show that just a certain amount of information is. And that's what these theorems are going to be discussing. So we're going to be able to apply in this lesson side, 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 which is SSS, and side, angle, side, which is SAS, to construct triangles and solve problems. We're going to be able to prove triangles congruent using these theorems. This is going to be a big theme as we go through this lesson, is the whole concept of proving. Okay? So we're going to be doing lots of proving. Get ready. Hopefully you're already ready. Okay. I lost my colors. Where'd they go? I don't know where my colors went. I'm sad. Oh well. Okay. Moving on. Lesson 4.3, again, this is what I was talking about. We proved triangles congruent by showing that all 6 pairs of corresponding parts are congruent. We're not going to do that now. The property of triangle rigidity gives you a shortcut for proving. That's what these theorems that we're going to be going over will show you. For proving 2 triangles congruent. Again, it states that if the side lengths of a triangle are given, the triangle can only have one specific shape. Okay, so again, the lengths are given, we can only have one shape. So, for example, if I had a triangle with the three different side links. So I have this side, and I'll use side, side, side to get started. So I have these three sides, and I try to construct a triangle. Again, you would start, let's say, construct the bottom. I got this side. And then you would say, well, let me go ahead and put this side up. Now, you can put it where it goes in the same angle here. If you didn't, and say you moved it out here, this side wouldn't reach. You'd have this extra space. And you'd be like, okay, I can't make it fit. You have to bring it back over here for the points to touch. Whole concept here is there's only one triangle you can draw if you have these three sides. So there's only one triangle that, again, we'll be able to set up. And again, that'll bring up our side, side, side theorem. We have proofs, obviously. We'll go through these things. All right, so there's our side, side, side congruence theorem. So to prove triangles congruent, instead of showing that all three pairs of sides and angles are congruent, if all we know is that the three sides of one triangle are congruent to three sides of another, then we have congruent triangles. Now remember from 4.4 is that, you know, these triangles can be in all sorts of different orientations, but the congruent statement, all the corresponding parts need to be listed in the proper order. But again, we only need side, side, side now. This is going to be one of our next postulates. I kind of showed you, I think I said theorem, sorry. I kind of showed you just, again, how we can draw it. I don't have to do a full proof for this. I can just draw the three sides. I can literally give you three sticks and ask you to make a triangle. And if you have those three sticks, there's really only one type of triangle you can draw, because those sticks would kind of come together at only one point if you decide to make a triangle. So since you can just draw this, you know, to go through a formal proof, again, you can just call this a postulate. So again, just concepts to remember here: adjacent triangles share a side. So, so this is like, you'll see this in some of our proofs. We'll have two triangles here. All right, sorry. So if I had a triangle, I'd have three sides. And I was going to kind of talk about these adjacent sides. That's going to be a side that shows up in both triangles. So like if I drew a side right down the middle here, this would be adjacent, an adjacent side, because two triangles, say triangle ABC and triangle BCD, would share this side. This is going to be my adjacent side. So again, the thing to remember here, adjacent triangles share a side, so you can apply what's called that reflexive property. I remember I talked about that in chapter 2. We don't really use it that much until we get to this point, to get a pair of congruent parts. Okay, so that's something we'll need to keep track of when we do our proofs. Okay, so part of going through talking about adjacent sides, we'll use it to explain why two triangles are congruent. Now we can do this in just an explanation problem, or we can do it as a proof. All right, so let's go ahead and get started here. So anyway, we're going to use side, side, side to explain why these triangles are congruent. So right now we have two congruent pairs of sides. So we have side here and side here. So right now what we have is we have that AB, oops, let me get that, AB is congruent to, and if I look at AB, I'm looking then at also CD. So I know these are congruent. That's a side. So that's a side. I have AD. Well, AD is congruent to CB. That's a side. I need to show my final side, which basically says that AC is congruent to AC. And that would be my final side. Now the reason for this is going to be that reflexive property. So if I was going to list out this, explain why these are congruent, use side, 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 you would have AB is congruent to CD, AD is congruent to CB, and that's given. AC is congruent to AC by the reflexive property. Therefore, you can say that triangle, and I'll go ABC, is congruent to triangle CDA by And again here we just say side, side, side. There's your reasoning that goes along with it. Alright, so that's going to be, again, using reflexive properties to show triangles are congruent. Alright, so that's a quick example of side, side, side. Now I'm going to talk real quick about side, angle, side. We're going to kind of get that set up here in just a second. But before we kind of talk about side, angle, side, I want to talk about, again, the angle part of that. We didn't have to worry about angles with side, 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 but we do with side, angle, side. So with side, angle, side, we need to understand what an included angle is so that we know if we're dealing with this, this postulate or not. So an included angle, is an angle formed by two adjacent sides of a polygon. So here angle B is the included angle between AB, segment AB, and segment BC. Now again, A would be the included angle between AB and AC. You got to think the two rays that form the angle are going to be the two sides that we use when we're comparing side, angle, side. Okay, so B is again the included angle between the sides AB and BC. Okay, moving on. Also, it can also be shown that only two pairs of congruent corresponding sides are needed to prove the congruence of two triangles if the included angles are also congruent, which is the definition or explanation for our side, angle, side postulate. So our side, angle, side postulate, notice here we have two sides and an included angle. Again, one has one tick mark, one has two, so you can kind of see which one stands for what. Here we have a tick mark, we have two tick marks, we have an angle included in between. This is a side, angle, side relationship. Again, side, angle, side does not mean that you just have two random angles and a side congruent. The angle has to be in between or included in between the two sides. It's not angle, side, side, or side, side, angle. It's side, angle, side. Again, the order that they list it matters. So here, this would be side, angle, side, side, angle, side, so I can say the triangles are congruent. Alright, so again, I was kind of talking about this, so you can just read that. It's what I just said. The letters side, angle, side are written in that order because congruent angles must be between, in between, pairs of congruent corresponding sides. Alright, so again, order matters. Alright, so real quick, again, we're going to use side, angle, side to explain why these triangles are congruent. So in this case, let me kind of write this up. I got side, I'll do it this way this time, side, angle, side. Okay, my sides here, I have to use my angle in between, but I got my sides that are given. I have BA is congruent to BD. So that's my side that was given. My angles, it looks like I have, and again, you can't just say angle B is congruent to angle B because there's two angle B's. Actually, there's three if you think about A, B, D. So you have to say, in this case, angle A, B, C is congruent to angle DBC. And that's going to be all given. So if I was doing a proof, we'll have a proof at the end here so you'll kind of see. But I was doing a proof, those would be given. Now I do need to find one more set of sides, and this is the one, again, we're using that reflexive property, and that is BC is congruent to BC, and again, that's the reflexive property, and let's say of congruence. So with all these things, I have side, angle, side. You can now say triangle ABC is congruent to triangle DBC by side, angle, side. And it's a postulate if we want to kind of put that in there as well. Alright, again, this could be a proof or not. It just depends on how they're asking you to do it. It's just use side, angle, side to explain. But this could easily be stated to prove that these triangles are congruent. And these would basically be the steps: given, reflexive property, and your final statement. Alright, so again, just kind of wrapping this up before we go into our proofs. I do need to finish with some proofs. That's what this chapter is mostly going to be about. We have the side, angle, side postulate guarantees that if you are given the lengths of two sides and the measure of the included angles, you can construct one and only one triangle. Alright, and that's, again, the postulate says that these triangles must be congruent if we have this relationship, which means there's only one triangle we can have, and they have to be congruent. Alright, so now we're going to kind of get into some examples to wrap up here. I'm going to get to our proofs here right after that, and then we got our quiz, okay? So 2 examples in our quiz, and we're almost done. Alright, so here we got show that these triangles are congruent if t equals 4. So if I'm looking at this example, we're just trying to show if we had a side-side-side or side-angle-side relationship. Well, in this case, we are going to kind of look more at a side-angle-side relationship. Now again, notice these triangles share side DB. So if they share this side, then I need to show that these sides are congruent and these angles are congruent. Now if they're congruent, that means that we should be able to say that 3t plus 1 equals 4t minus 3. But because see how these are both t, whatever I get for t here, if I plug it in for my angle, I should get 32. If I don't, then this is not congruent. These triangles aren't congruent because I won't have a side-angle-side relationship. Well, let's start out here by plugging in my t equals 4, and let's see what I get. So this would be 3 times 4 plus 1 and 4 times 4 minus 3, and see if I get that. So 12 plus 1 is 13, and this is 16 minus 3, which is 13. So that works. Now let's check my angles. I should know that 2 times oops, did that wrong? No, didn't really do it wrong, but 2t squared equals 32. See if this works. So this would be 2 times 4 squared equals 32. Well, 4 squared is 16, and 16 times 2, well, it's not, oh, I wrote 36, that's my problem. Okay, so I say, oh, well, that's not going to work, but it will. I just wrote my number wrong, so that'd be 32, sorry. So 16, 4 squared, times 2 is 32. So these are actually equal. So again, show that they are equal. So I would say triangle ADB is congruent to triangle CDB by side angle side. But again, this is more about the work. You don't just write the statement and say, all right, I got it right. You have to show it. So the work has to be attached if they're saying show. Not just good to write the statement. That's not going to be good enough. It's the work that I'm looking for. Okay. Alright, so to wrap up again, I'll give you a second if you want to write this down. Get the statements and reasons written up so we can do our proof. Okay, so for this one, I'm going to go ahead and write up our proof for, we're trying to prove now that these triangles are congruent, so we can use again side angle side or side. In this situation, it looks like we're going to use side angle side. So looks right off the bat, we got QP, ray QP bisects angle QRS, which I have here. So I'm going to write given right off the bat. They say QR is congruent to QS. Well, it looks like that's cut off, so I'm going to put that in as step 1. So QR is congruent to QS, and that's given as well. Sorry, my phone's going crazy. I'll move that. Okay, so I have these are given. I'm going to go ahead then and use what I know to fill in the rest here. I'm just trying to find a good color right now. So I know because QP bisects RQS, I know these angles are congruent. Okay, because of the bisector definition. So I'm going to say definition of bisector for my next step. And then next up, I know that QP is congruent to QP. I know that because of the reflexive property of congruence. So now I have my side angle side relationship. Hopefully you can see the included angle in there. It's the angle in between the two sides. So these triangles then are congruent by the side angle side postulate. So again, hopefully you're writing down these reasons, keeping track of them as we go through this chapter. Reflexive properties getting used. We've used definition of bisector already. We're still using it. So hopefully you're kind of getting the hang of those. So these proofs won't be so bad because they're really going to start adding up here in these next few lessons. Alright, so with that we got our lesson quiz. There's 2 parts to the lesson quiz. Part 1, again, show that these triangles are congruent when x is 6, just like the example I did in the notes. Plug in for x, and then see if we're going to have side angle side or side. Okay, but you have to show the work. Don't just write the statement that the triangles are congruent by whatever postulate. I need the work. Number 2 and 3, again, which postulate can be used to prove the triangles congruent? Again, sometimes you may have to, here you can probably add some angles and stuff, but again, add as much as you can, and then look and see, is it side or side angle side? Okay. If you don't get either one, then you say neither. Part 2, we got a proof. Pretty self-explanatory, right? Fill in your given statements and go from there. All right, so we got our proof for number 4. And with that, fill in your reflection, and I'll see you guys in class.